Hi everyone. So today we're going to be using our properties of radicals and rational exponents to solve some radical equations. And I think many of you might like this lesson a little bit more than the last 2 weeks, just because it's very procedural and there's kind of steps to follow in place or in order. So I do have a few different types of equations that I'm going to show you today. So you might want to make notes on each one so that you have some examples for when you go to complete your Canvas quiz. So the first one I have is x to the power of 3 equals 64. Now we solved very similar problems as this in Unit 2 on quadratics. So if I wanted to get rid of that cube, I am going to use my opposite operation. So the opposite of cubing something would be to take the cubed root, just like we use square root method back with quadratics. So I would take the cubed root of both sides. The cubed root and the cube end up canceling each other out, so I'm left with x equals the cubed root of 64. And again, to use my calculator to do this, I would go to math. I have a cube root symbol, number 4, of 64, and I get 4. So x equals 4. In a little bit, we are going to talk about extraneous solutions, but with any time you are solving an equation, you want to make sure you take 4, substitute it back in, and make sure that it works. So for example, if I take 4 to the power of 3, do I in fact get 64? And that would come out as a true statement. Number 2, we have 2 times x to the power of 4 equals 162. So like any other equation, you want to start by isolating. So in order to do so, I'm going to divide both sides by 2. So I end up with x to the power of 4 equals 81. And then like the last problem, since I have x to the power of 4, the opposite operation would be to take the fourth root of both sides. Now, similarly to quadratics, when you are taking an even root, for example, the square root, the fourth root, the sixth root, I need to make sure I include a plus or minus in my answer. So I'm actually going to have 2 solutions. So it ends up being x equals plus or minus the fourth root of 81. Now, the fourth root of 81 is 3, but if I need my calculator to assist me in this, what I'm going to have to do first is write the actual root that I'm looking for. So I'm looking for the fourth root, so I'm going to type a 4. Then I go to math. Number 5, I have this x and then the radical. The x allows me to put in any root, such as the fourth root. So then I would type in, whoops, I must have hit the wrong one there. Let's try this again, number 5. The fourth root of 81, and again we get 3. So on a Canvas quiz, you would have to type in positive 3 and negative 3, just as a reminder there. Okay, 3 and 4 are slightly different. So this is going to be kind of the opposite process that we did for the first 2. So like any other equation, I isolate first. So since I have 5 plus the square root of x plus 1, I'm going to subtract 5 from both sides. So I get that square root of x plus 1 equals 11. And then the opposite of square rooting something would be to square it. So I square both sides. The square root and the square cancel each other out. So I'm left with x plus 1 equals 11 squared, which is 121. Then I subtract 1 from both sides. So we get x equals 120. Likewise for number 4, I'm going to isolate as much as possible. So when you're isolating, you want to slowly work in on your variable. So since I have 2 times the cubed root of 5 minus 11x plus 2, I'm going to start by subtracting 2 from both sides. And then I'm going to divide both sides by 2. So I'm left with the cubed root of 5 minus 11x equals 3. Well, the opposite of cube rooting something is to cube both sides or raise it to the power of 3. So I raise both sides to the power of 3. The cube root and the cube cancel each other out. So I get 5 minus 11x equals 3 to the power of 3, which is 27. I would then subtract 5 from both sides, and then divide by negative 11. So my final answer is x equals negative 2. Making sure I then take negative 2, substitute it back in for x, and make sure it still works. Okay, for number 5, notice I have one square root on each side of the equal sign. So in order to get rid of that square root, I'm going to square both sides. The square root and the square cancel each other out, so I end up with 3x equals x plus 6. This is just a linear equation. So then I would subtract x from both sides, so I get 2x equals 6, divide by 2, and my final answer is x equals 3. Now, number 6 looks a lot more complicated, but it's really not. My first goal is just to make sure it looks like number 5. So I want to actually add the square root of x to both sides so that I have one radical on both sides of the equation. So I get the square root of 3x minus 2 equals the square root of x. I'm then going to square both sides to get rid of those radicals. So I end up with 3x minus 2 equals x. Subtract 3x from both sides, and then divide by negative 2. So x equals 1. Okay, so I have one more problem for you. And here's kind of my hint. This problem is going to include an extraneous solution. So remember, an extraneous solution is a solution that when substituted back into the equation, it does not actually work. So it doesn't mean you made a mistake, but the solution just does not actually work. I usually call them the trick solutions. So I have x plus 7 equals the square root of 2x plus 7. The first thing I really want to do is get rid of that square root. So in order to do so, I'm going to square both sides, putting that left-hand side in parentheses. So I end up with the quantity of x plus 2 squared equals 2x plus 7, because the square root and the square cancel each other out. Now, on that left-hand side, make sure that you are actually multiplying this by itself and distributing. So I'm going to write out x plus 2 times x plus 2 equals 2x plus 7. I would then distribute that left-hand side. And then combine like terms. Now, in order to solve for x, I need to set this equal to 0, because you might already be thinking, okay, I see that x squared, this means I'm going to have to factor. So I would subtract 2x from both sides, subtract 7 from both sides, so we get x squared plus 2x minus 3 equals 0. And then I'm going to go ahead and factor that left-hand side. So I have an x and x. I need two numbers that multiply to 3 and add to 2. So 3 and 1. And we need to multiply to negative 3. So I'm going to make the 3 positive, the 1 negative. Because 3 times negative 1 is negative 3. 3 plus negative 1 is 2. So I end up with two solutions. X equals negative 3 and x equals positive 1. Now I can tell you right now, one of these does not work. So I'm going to pause the video for just a moment, check my work, and I'll explain which one does not work. Okay, so over on the right-hand side, I showed my work for both negative 3 and 1. I substituted each solution back into the original problem and then checked my work. So for x equals negative 3, you'll notice that I end up with negative 1 equals the square root of 1. Well, the square root of 1 is 1. But does negative 1 equal negative 1? No, this is not true. So I would actually cross out negative 3, and then I'm going to check x equals 1. So when I substitute that in down here, I end up with 3 equals the square root of 9, which is actually 3. because this is a true statement, I know that my actual solution is x equals 3. So that is all for our radical equations today. We'll solve another type of equation then on Thursday.